session. Okay, so last time we were discussing data and process modeling, and under that we discussed a couple of ideas, but mainly we focus on data flow diagrams. And under the data flow diagram, we discuss 4 basic symbols: the process, data flow, as well as data store and external entity. And there are various representation, and then we will stick into the first set in our session. Now, when you are creating or drawing data flow diagram, we discuss some guidelines. First of all, when you're drawing context diagram, you should try to make it fit to a one page, and in the center, you can have the information system as a single process. And then around that, you can have all the external entities and then the data flows. And then lower level data flow diagrams, we can use verb with the noun. So for example, if you take the grading systems as the context diagram, we can say, okay, establish grade book, assign final grade, produce grade report, and so on. And remember to use unique names for each of these symbols, and then give a name as also reference number. So there are various ways people are used, but what we discuss is for the context diagram, we should start with process 0, and the next level our processor should start as 1, 2, 3. And when you go down in one of these processors, let's say 1, then you should go down as 1.1, 1.2, and 1.3, and so on. Right. And then we discuss 2 examples for how to draw a data flow diagram. As I told you earlier, the single process, we referenced it as 0, and we named it as a grading system. And around that, we place all our external entities, and then we identify all the data flow. Remember, when we identify data flow, it's just the name, the data item that we are sharing, right? No verbs are involved if you carefully look at. For example, in grading system, it will output a final grade. And here it will take the class roster and so on. And then when you go down, right, we discuss in level 1, then we can go into detail, right? So for example, going from grading system 0, then we break it into sub-processors as 1, 2, 3, and 4. And then there we will have processors, external entities, data stores, because we didn't have data stores in the context diagram. And then we have data flow. Again, remember, these should be represent the data item. There's no verbs involved in here. But we use verbs when you're representing name for the processors. Right. Okay, so these are the ideas that we have actually discussed, last time. Right. Okay, then we are going to discuss some other ideas. The next idea is data dictionaries. Now, data flow diagram, we produce a logical model, right? Then the details we have to put in data dictionary, right? So this is the second part of the structured analysis. You have to have data dictionary. So what is data dictionary then? So you can say the data dictionary is the place where you are going to keep information about the system's data. So analysis can use this data dictionary to collect, document, organize, facts about the system. So this include the content of data flows, data stores, entities, the processes. So simply you can say the data dictionary define and describe all the elements and all the combination of data elements in a meaningful way. Right. So what is a data element there? So when you say a data element, we can also call it as data item or a field. That is the actually smallest piece of data that we can talk about within an information system. For example, when you say a student grade or person salary, social security number, it's like national identity card number, account balance, company name. So all those are examples for data elements. Then we talk about the data records, right? So when you combine all the data elements together, we can make a record, right? So we can say a meaningful combination of these related elements are called data records, right? So this is what we are going to keep in a data store. Now, for example, if you take auto parts store, and then you can have part number, description, supplier, minimum stock level, maximum stock level, cost, list price, and so on. So this will, create a record for the auto parts store. Right. Then the next one. Now, when we have processes, we need to have a way of describing the process. So this is called process description tool, right? So for example, we can talk about a particular set of steps. We can say specific set of process steps. And also there will be some logic, right? So using these process description tools, we can model it. So when you create a model, it will be accurate, it will be complete, and it will be concise, right? So when you talk about these different types of process description tools, there are various ways we can represent. One is you can use structured English, that means simple English statements to represent this. You can create decision table, or you can create decision trees. Okay, so let's look at each one of these to understand what you mean by process description tool. Right. Now let me start with the first one. The first one, we call it structured English. That means you use standard English to define each of the processes. So when you talk about each of the processes, we can talk about sequence. When you are, have processes one after the other, you can have selections based on some condition you can do. You can have iteration, which means you can have repetition. Now let's take an example to explain this. Now let's say we are going to decide on customer order based on their credit state and also the product availability. So which means, the credit status should be good. We can say yes. Product details also should be, you can say okay. If you have all these, then you are going to accept the customer. That means customer should have a good credit without any, issues of, paybacks and so on. Right? Products also should be available. If both conditions are satisfied, let's say we are going to accept the order. Now, when you want to write down this in structured English, so the repetition we represent like this for each order. So that means we are going through each order one at a time. And then for each order, within that, we have a selection. In each order, we will check whether the customer status is okay. Right? And also product details okay. That means the product is also available and customer credit is also good. If both conditions are met, we are going to say, okay, accept order. Else means if one of these fails, we know that this is not going to accept. So we can say, okay, rejected order. So simply, this is how we will represent like structured English. It's like a pseudocode, right? When you're representing your algorithms, you use pseudocode. Again, the simple English. We will use a similar way, a process Remember here we described a processes in information system. We can describe using structured English. Right. Now let's move on to the next one. Similar to a structured text, we can create a table structure. So a decision table, it's a structure and it'll show you all possible combination of conditions and outcomes, right? Therefore, analysis often use decision table to describe a process, right? Because you can use to see all possible situations. Okay, now let's look at an example. Now, let's say the same problem, right? Same problem, right? That means we are going to have two conditions. The order is going to accept if the product is in stock, that means product is yes, as well as customer credit is okay. And all possible other orders, we are going to reject it. Now that means we have two conditions, right? The first condition is customer credit status. We want to check whether the credit status is okay. Second condition is whether the product is in stock. We have to have the product. So we know that when you have two conditions, we have two possibilities. It could be yes or it could be no. So since we have two values, we can have four combinations. So the first situation, it could be yes, both. So that means credit status is okay, yes. Product is in stock is yes. The second one, yes, no. Third one, no, yes. Last one, no and no. Right? That's the conditions. Then after the condition, we put up actions. And in this example, we have two actions. Either we have to accept order or reject order. So we know that when both conditions hold, we are going to accept. So that's why we have a cross here to say that, okay, when both conditions are yes, credit status is okay, as well as product is in the stock, okay, we are going to accept the order. And all the other cases, we are going to reject the order. So here what happens, credit status okay, but product is not in stock. So we cannot proceed. Here, we have the product, but customer's credit status is not okay. So you are going to reject the order. Last one, you have both. You have both, right? You have to say a reject order. So let's compare again. Now here, we are going to have it like a structured English. That means for repetition, selection, we have some standard statement. So for the repetition, we have a for loop, and selection, we have a if, and so on. And when the customer status is yes and the product is in stock, then we are going to accept the order. Otherwise, we are going to reject the order. So in the decision table, we first identify conditions. So we have two conditions, which means there are four combinations. Then we have two actions. So for each of these combinations, we have to check whether we are going to accept or reject. And all possibilities we can represent using a decision table. So this decision table of verify order process. Right. Now we have finished the structured English. Then we discuss the decision table. Let's move to the next one. Right? Okay, we have a small question. Shall we start with this one then? Right, try this. So we have given a small description and we need you to create a decision table. Right? So first one, preferred customer who order 1,000 or more entitled to have 5% discount, an additional 5% discount if they use our charge card. Preferred customers who do not order 1,000 or more will receive 25 bonus coupon. All other customers will receive 5 bonus coupon. Right. So I'll give you about 5 minutes. Can you work on this and maybe you can share your answers in the WhatsApp? Right. The first of all, we need to identify how many conditions are there. Yes. How many conditions we have? So if you remember our previous one, right? You can see, first of all, we need to identify the conditions, right? We have to have conditions. So what are the conditions we have? Yes. Can you type in the chat? What are the conditions? Yes, how many conditions we have? Can you type in the chat? Right. Now, first of all, you need to identify how many conditions are there. Can you read this again and identify what are the conditions? So one thing is we have preferred customers, right? We have preferred customers. We have preferred customers. See, we have preferred customers. What are the others? Right. The next one, we can see ordering 1,000 or more, another condition. Any other conditions? We can see whether the customers are preferred or not. Yes. Isn't it? whether they have ordered $1,000 or more, right? And then if they use their charge card, right? So these are the conditions, right? So in the table, what needs to be done when you're creating a table, right? So we have to put up the conditions. Conditions. Right? So the first one is preferred customer, order 1,000 or more, used our charge card. So you have three conditions. What are the actions? What are the actions? Yes, guys, what are the actions? Yes. Can you tell me what are the actions? Right. Look at what are the conditions, actions. So if you look at carefully, you can look couple of things, right? So the actions, the first one, 5% discount. You can have 5% discount. Then additional 5%. So I don't have enough space here, so I will put it here. So these are the actions, additional 5%. What else, guys? Then we can have 25 boards. Then $5. Right. Now, there are three conditions. If you have three conditions, how many possible combinations are there? Yes. How many possible conditions? So we can have yes, yes, yes. This is what? All the three conditions meet. Then we can have yes, we can have yes, we can have no. So we can have yes, we can have no, we can have yes. right? Then we can have yes, we can have no, and we can have no. We can have no, we can have yes, we can have yes, we can have no, we can have yes, we can have no, we can have no, we can have no, we can have yes, and finally we can have yes, we can have yes, we can have yes. Sorry, other way around, it should be no, right? Now can you put up the values here? So here are the action items. Yeah, can you put up the cross here and share me in the WhatsApp? Right. Now, in this description, we have sales promotion policy, and based on whether the customer is a preferred customer or not, and based on whether they have spent $1,000 or more, right? They will get different discounts. So if they are preferred customer, and then if they order $1,000 or more, right, then you will get 5% discount, right? So preferred customer, yes, and then 1,000 or more, then 5%, right? So we can do that. We can check that. So that means preferred customer and order 1,000 or more, yes, 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 yes. Then we have a 5% discount. So we have one cross here, right? And then another cross, because both of them get 5% discount, right? And if both of them, and then if they use the charge card, then you will get additional 5%. So here you will get another additional 5%, right? You will get additional 5% discount because they have used charge card here as well. So you will get totally 10% discount, right? If you are a preferred customer and if you order 1,000 or more and you use a charge card, you will get 10%, right? And if you're a preferred customer and order 1,000 or more only, then you will get 5%. Then let's say you are a preferred customer, but you do not order 1,000 or more. So all the preferred customers, but if they have not ordered 1,000 or more, right, we will get 25. So that means these two conditions, we are getting 25 bonus, right? So 25 bonus for these two. And all the other customers that the remaining, you will get 5%, $5. So the remaining 4 cases, right, we are getting, okay, $5 bonus. And this is how we will represent in a decision table. Okay, those who have understood, can you please raise your hands? If you have understood this, please raise your hands. Keep on raising your hands. I want to see like how many of you have understood. Right. Actually, it's about 1/3 of the class. So maybe I will explain again, right? One more time. So whenever when you're given a question like this, right? That means we are going to analyze a particular decision we want to make using a decision table. So we have to separate out the conditions and then the actions. So this description is about the sales promotion, and it says if the customers are preferred customers, that means sometimes we call loyalty customers, some shopping malls offer loyalty customers, and then you will get, discounts. So similar here, if you're a preferred customer, and then if you order 1,000 and more, and if you use a charge card, then you will get different bonuses. So as the first part, we need to identify these 3 conditions. That means we need to figure it out whether the customer is a preferred or not, whether they have ordered 1,000 or more or not, whether they have used their charge card. So you can see we have 3 conditions. If you have 3 conditions, then there will be 8 possible combinations. What do you mean by 8 possible combinations? We have 3, and it could happen that all the 3 could be yes. Then we will have yes, yes, no. Then yes, no, yes. Yes, no, no, and so on. So if you look carefully, there's an interesting pattern here. Like in Boolean, when we have truth tables, we have yes, no, yes, no, yes, no, yes, no, right? And here we have 2 yeses and 2 nos, 2 yeses and 2 nos. And here we have 4 yeses and 4 nos. So you see there's a pattern. Now the first part is you identify the conditions and then put up all possible combinations. Then you have to identify the actions. When you go through the action items, you see that they are giving 5% discount. They are giving additional 5% discount. They are giving 25 bonus, and they are giving $5 bonus. So which means these are the 4 sections. Now you can go through the script again. Now, when you say preferred customer, then this should be yes. And if they order 1,000 or more, that means this also should be yes. Right? So preferred customer, and if they order 1,000 or more, you are getting 5% discount. So we have first 2 cases, we are getting 5% discount. At the same time, if you if you use their charge card, you are getting additional 5%. So in this first case, we see that they are preferred customer, they have ordered 1,000 or more, and they have used a charge card. So the person is entitled for additional 5% discount. Additional 5% discount. Okay. And if you do not have used our charge card, it's only 5%. Right? So we have worked with the first 2 cases. Let's look at the third one. It's a preferred customer that they have not ordered 1,000 or more. So if the customers are preferred customers, but they do not have opened 1,000 or more, you'll get 25 bonus coupon according to the second one. So for the third and fourth one, actually those customers will receive 25 bonus coupon because they do not order 1,000 or more, right? Okay, that's what you need to understand. Lastly, if the customers are not preferred customers, last 4 cases, simply you are getting $5 bonus, right? And that's how we will create a decision table. Right. Now, decision tables are good, but you can see that it's a bit complex as well, right? Especially when you have a large number of conditions, large number of actions to make. This is a bit complex. So there's a more easiest way to do this. So how do you do this easily? We can generate a decision tree based on this. We can create a decision tree. So let me explain how we can use a decision tree here. Right, now for each of these, when you use statistics, especially in combinations, you might have used decision trees. So we know all these conditions, you have 2 outcomes, either yes or no. So you evaluate one condition at a time to put it as a tree structure, right? So you take preferred customer, right? So let me draw, I'm going to say, okay, preferred customer, let me say PK. So you have 2 possibilities, yes and no, right? Yes and no. Then the second condition is whether they have ordered 1,000 or more. So you check that next. That also you have 1,000 or more, yes or no. Then you go for the third one, whether they have used a charge card or not, charge card or not, charge card or not. So likewise, you can populate as a structured way. So this is called decision tree. Okay. So let me show you how we can do this. Right, let me clear everything. We'll move to the next one. For same problem, here is how the decision tree look like. So first you ask whether you are a preferred customer, right? So that's the first part, right? So you put this line, you will ask it's yes and no, right? And then if it is a yes, then we can ask more, because if it is no, there's no point of checking this one. So in this side, I'm going to ask one more question. When you are a preferred customer, the next question I'm going to ask whether you have spent 1,000 or more, right? So the answer could be yes and no. Then if you have ordered 1,000 or more, the next question I can ask whether you have used a charge chart. That also yes and no. So you now know, see, there are 4 outcomes. If you are a preferred customer, and if you order 1,000 and more, and if you use a charge card, then you will get 5% discount and an additional 5%. So totally 10% discount. If you are a preferred customer, if you ordered 1,000 or more, but you have not used a charge card, then you will get 5% discount. If you're a preferred customer, but you don't have ordered 1,000 or more, then you will get 25%, $25 bonus. Simply, if you're not a preferred customer, then we'll get $5 bonus. So you can see, compared to the decision table that we have seen, this is more easier to represent. This is easier to represent. Right. Okay. Now that we have got an idea, I would like to go back again just to compare with the previous one, right? Just try to understand what we did. So we have, a couple of ideas that we need to check. So depend on the condition, we knew that there are 3 conditions. And then the first question that we have posed is whether the person is a preferred customer or not. If it is a no, you don't have to answer these 2 questions in our case. So if the person is a preferred customer, then you can ask whether they have ordered 1,000 or more. And if whether they have used a charge card. So depend on these 4 combinations, we'll get different discounts. Okay. Now let's try to understand this by going through one more example of creating a decision tree. So let's start with this example. Okay, first try yourself, and then we will discuss how to implement this in decision table as well as a tree representation. Okay, let's start coding. Right. Now that we have talked about the data modeling, so this part we are going to look at tools and techniques available in object modeling. Object modeling is another idea that we use, especially when you develop software using, let's say, object-oriented programming languages. This modeling is very important. So in this part, we are going to look at how we can make use of object modeling. Right. Let's start. Now, this object-oriented methodology, we can easily make use of with object-oriented programming languages, right? So mainly object orientation is quite popular. It's a modular and it's reusable. And if you think about the code maintenance, it will be easy compared to, other types of modeling. The main item that we are going to discuss on the object orientation is we call object. And this object usually represent a real person, place, event, or any other transaction. By the way, I got the answer from okay, good. I mean, Jaratna, your answer is correct. Huh? Thanks for sharing the answer. Right. Let's back to the object orientation. Now, let's look at some examples. Let's say we have a patient, and let's say the patient wants to meet a doctor. Usually we make an appointment. So if you take that particular statement, we know patient is an object, doctor is an object, and if you take appointment itself, is an object. So when we talk about the object-oriented analysis, what we do, we look at the objects as functions and then how they interact each other. So once you finish the object-oriented analysis, what you get, the outcome, is known as object model. So this object model represents the information system, but using object-oriented concepts in terms of objects, right? And that is exactly what we are going to discuss. So let's briefly discuss the core concepts. The first one, we start with the objects. As I told you earlier, object could be anything. It could be a person, it could be a place, it could be an event, or it could be even transaction, right? So these should be significant to the information system. But in addition, when you take objects, you have to have both data as well as processes. So let's take an example. Let's take a customer. When you take a customer, customer has a name, customer has an address, customer has an account number, and the customer, you have a current balance. Then these objects can perform various tasks like placing an order, paying a bill, and changing their addresses. So in this graphic, you will see an object. And when I say object, the object representation, we have object name. And then usually we have attributes which describe the, let's say, parent. And then there are methods which will affect on other objects, right? So those are called methods. Now, this object is like a blueprint. It's like a template. And real objects, that means what we call instances, may carry the values. Now, for example, in this example, you see we have 3 instances. And the first instance, if you take, it says Mary Smith. That is the name. Age will be 25. And the gender will be female. And the hair color is red. Right? Hair color is red. Similarly, take another example. Instance means like what real, right? The values of this parent object. So here we have Ahmed Ali. Age is 34, male, hair color is brown. Anthony Gina, age 42, male, and then hair color is brown. So you see the graphical representation of parent object as well as the instance of the parent object. Similarly, another example. This time we have dog object, and then we have a set of attributes and set of methods. So when you talk about the instances, it considers only the first part. You have name, breed, age, color, we have gender, right? And then you can have some favorite food as well. Right. We have already seen some attributes, but let's formally discuss what attribute is. So when you take attributes, basically the characteristics of an object, it describes the characteristics. So sometimes object can inherit or acquire some attributes from other objects. So when you take objects, you have a specific attribute, which we call state. And state can be different values. Like, for example, when we have a student could be a future student, a current student, or a past students. Right? The next one is, next example, bank accounts. We have different phases. We have active, we have inactive, we have closed or frozen. So those are the attributes. So now let's compare two things together. One side we have a student object. The other side we have an instructor object. And then we have set of attributes. So student, we have student number. Right? And then we have instructor object. So you can see instructor object, we have a different set of attributes. And apart from these, we have set of methods as well. Right? So we have a set of attributes as well. So this set we could use, for example, student, we have student number, name, address, telephone, date of birth, fitness record, and status. Similarly, instructor also we have another set. So there, some attributes are common, some are actually different, right? Now let's look at some methods. So when you look at the methods, again, there are some common ones, right? Like, for example, there are some common methods like change address, could common for both objects, right? And then when you take fitness class schedule, so this is about a fitness class where the student is who's attending the fitness class and the instructor is there. And then there will be a fitness schedule. So in fitness class schedule, you can see there are attributes like fitness class number, the date, time, type, location, and then there are a set of methods adding to the class, right? And then what you have is delete class, change date, change type, right? Change instructor, right? Similarly, if you have another object here, we have registration record, we have attributes, and then in registration record, we have student number, fitness class number, registration date. And similarly, there are some methods where we can use add student, drop student, and so on. Right. Now that we talk about the attributes, we can talk about the method. Now, the methods we have already seen, right? But you have to have some steps. Now, in this example, you see a detail of the methods, right? You have, you can see more fries, that's the method name. And there are some steps involved in this. right? So that means you can say that it defines some tasks, right? Object can perform. Another example. So in this one, you can see adding a student. So you can add student instance. Then you can record student number, name, address, telephone number, date of birth, gender, and state, and so on. In object orientation, we have message passing among these objects, right? So messages can be used to instruct the object to perform some method. So methods can be used to actually make the interaction possible. So for example, if you take a student object, you can see we have an add student. Now, when you say add student, you can actually perform the steps to add a particular student instance. Similarly, when you take delete student, you can actually perform steps to remove a student. Right. Another example. Now, when you use like object orientation, we have different interactions. Like, for example, now in this example, we are going to talk about idea of polymorphism, where when you use same message, but different objects can different results. They can produce different results. Now, in this particular case, let's say we have message good night. We have a parent, we have a dog, and we have a child. So these objects may work on different objects, like differently, right? So maybe a parent may read a story to a child, and child is getting ready for the bed. The dog can go to sleep. Right. The next one is about the classes. So we have class. Simply all the objects in a particular group, we can make it a class. So simply we can say all objects in the class, they will have same attributes and same set of methods. And then when you have objects with the class, we can group into subclasses. So these subclasses are very specific, right? Let's see some examples later on. But we can group into more specific classes, which we call subclasses. So look at this example. So we have a vehicle class, and we have a set of attributes. We have make, model, year, weight. So these are like what we call common attributes. So all the subclasses, we have car, minivan, truck, school bus, they all share these common attributes. Similarly, we have common methods as well. Now, for example, here we have a start, stop, and park. These are all common. And these methods also shared within the subclasses. Now, what is the specialty of the subclasses? Now, subclasses can have like very specific attributes or very specific methods within the subclasses. So for example, you can see here the truck. We have a load limit. It's an uncommon attribute. That attribute is only specific to truck. So you can see it's only specific to truck. Similarly, if you take school bus, so emergency exit location is a very specific attribute only for school bus. Right? So the subclass can actually inherit, we call it. Inheritance means they can make use of all the common attributes and common methods. Right? And then there could be some uncommon attributes. Now let's look at another example. So now in this example, you see so in this example, you can see we have employee. So we have like name, date of birth, social security number, telephone number, hire date, title, pay rate, and status. Now these are like common attributes. So these are common for the subclasses like manager, office staff, and instructor. And then there are some common methods. We have get hired, terminate, right? So these are common. But then if you look at the instructor class, instructor subclass, then instructor subclass, we have a very specific attribute, instructor type and availability. Now this is only common, right? So this is only specific to instructor class, right? Very specific to instructor class. So you can see that when we have a classes, so the objects within the class share the same attributes and the subclasses can inherit, which means the same set of attributes and methods can be shared within the subclass, but they can have their own set of attributes as well. Then now we talk about the classes and subclasses. Now, when you generalize this, right? The class, when you generalize, you can create superclasses. So let's see what superclasses are. Now let's say we have a class employee and we have a social security number, telephone number, hire date, and title, pay rate. And then we have get hired, terminate, change telephone. So these are some of the attributes and the methods. And we already discussed subclass instructor is inherits all the attributes from the class, right? Plus it has like two uncommon attributes like specific, instructor type, and the availability. And then we have a method. We have teach fitness class is another specific method. Now you can have superclasses. Now superclasses is more generic classes. Like in this particular case, you can see when I say more generic class, it means the person. So person class is more generic class, right? More generic class. So in this particular case, you can have name and date of birth. Then very general method like breathe, eat, and sleep. So now, when you create a superclass, usually the class can have all the attributes from the superclass as well. So you can see in this particular case, we have name and date of birth could be shared within the class as well, right? So because when you have superclass and class will be a subclass of superclass. Similarly, we can have breathe, eat, and sleep that can be inherit from superclass to the class. Right. Now, let's look at the relationships. So we know that when we have objects, we need to communicate and interact because we want to perform some business functions. And then we can use relationship to describe, right? And then we can talk about the changes. So we can make it changes to other classes. And you can also use to effects of the memberships, superclasses, and subclasses. So the term inheritance, which I have already discussed earlier, we can say a child to derive one or more fit attributes from another object called parent. So the idea of inheritance we use to say that we can get all its attributes as well as methods from other object. So in this example, you can see that. So we have a parent and the child relationship. So more specifically, you can say class and subclass relationship. This is what you see. We have a parent and child, employee and instructor. So instructor is an employee, right? So when you look at the instructor's attributes, all the attributes from the parent class, that is employee, is available. We call child inherits all the attributes from the employee. So in this particular case, you will see, right? All the attributes in the employee is available within the child. Similarly, we have methods as well. So all the methods available in the parent is available under the child, right? So we call child inherits all the methods, right? Child inherits all the methods. Right. Now, to represent these, we can prepare a diagram to see the whole system, which we call object diagram. And sometimes we call object relational diagram. Right? So this will give you overview of the system. Right. So let's now look at the object diagrams. Right. Now, in this one, in very briefly, shows you object diagram where we have superclasses and subclasses and then other relationships. Now, remember we talk about the employee class, and then we have manager, office staff, and instructor. These are like subclasses. So in this particular case, you see that employee is a manager. So manager is an employee, office staff is an employee, and instructor is an employee. So these are like superclass and these are subclass. So what it means, all the attributes and methods in employee inherits by manager, office staff, and instructor. And then there are some other classes, right? In here, fitness class schedule. So in this particular case, relationship is a determines, which manager is the one who determines the fitness class schedule. And then instructor will teach in the fitness class. The student will take the fitness class, right? And then you know that students will register. For the registration record, all the members are interacting each other. So for example, we have to have fitness class schedule, and the office staff will administrate it. Instructor indicates the availability, right? And depending on that, it will generate the roster where instructor and student take place in the fitness class. And the registration record will add the students. So this is a very brief overview of how the classes, or in other words, the object interacts, right? So this is called object relationship diagram. Okay, let's move to the next one. Now, when you look at these different diagrams that we are going to talk about within the object modeling, one of the main modeling language we use is called UML. And UML is actually used to visualize, especially when you want to visualize, as well as when you want to document the information system. We can use different UML diagrams. So there are many diagrams under this. For example, user case diagrams, class diagrams, sequence diagrams, state transition diagrams, activity diagrams, and so on. Now, for example, when we are going to implement the system, we are going to talk about what we call user cases, which means the user case diagram represent how users interact with the information systems. Then based on these user cases, we create class diagrams. In class diagram, we show the classes, their relationships, right? And then if you want to know exactly how it works, we create sequence diagrams. And then we also can use state transition diagram, changing the state. Like, for example, a student's lifetime, we can represent using state transition diagram. For example, when users enter a university, yes, you enter as a fresh, and then you go through the first year, second year, third year, and final year, then finally you graduate, and then you will become alumni, for example. So the state will change. So the change of state, we can represent using what we call state transition diagrams. And then we also have activity diagram. So I'm going to briefly describe like each of these with some examples. Right. Now, for today's session, I will start the user case modeling, and I will discuss a couple of use case diagram and we'll finish for today. The remaining parts we'll discuss in the next week. Right. Now, user case diagram, we can call it as a dynamic or behavioral diagram, right? So we can use it to describe a business situation. So when you say a business situation, there'll be a person, we call it an actor, right? And we have that particular actor interact with our information system. So when you say use case, it will represent specific situation, specific transaction. Now, let's say patient wants to make an appointment. So this stick figure represents the patient, we call it actor, wants to make an appointment. So this is called a use case, right? So these user cases represent the steps, right? Now, for example, when patients are meeting a doctor, first you have to make an appointment, right? Then you can, get the prescription, you can meet the doctor, and you can get the prescription. Likewise, you can have a sequence of use cases. So the actor is what we call the external entity because it's outside of the information system. So he is the one actually start, or we call initiate the user case. And that initiation means you request the system to do something. Now, in this particular example, what you see is patient is requesting to make an appointment. So actor, in case the outsider, actually requesting to make an appointment within our information system. So there could be many use cases. For example, passenger can request a making airline reservation. Customer can place orders. Bus dispatcher change pickup addresses. Likewise, you can see these are some of the examples. And the external entities or these actors can initiate this. Right. Now, the relationships, these lines actually indicate different types of relationships. Now, when you draw a simple line, it represent a relationship. But there could be different types of relationship. So you can have what we call users or include, or you can have extends. So the first part, that means users include relationship, to say that the user case is needed by another to perform particular task. So when you say users or include, that means it is needed by another, right? The second one we call extends. Now extend means some alternative options, right? Some alternative options. So arrow is actually indicating which user case actually being used. So the arrow is indicating which one is actually being used. So let's see some examples now. Now you can see student, we have add fitness class, and then the product fitness class, we say a users add fitness class, this use case. So we can say student adds a fitness class and produce fitness class roster uses the results of add fitness class to generate new fitness class roster. So this actually uses this to create a new fitness class roster. Look at the second one. We have instructor change availability and update instructor information will uses this use case. So instructor changes his availability. That means whether he could, take that particular class or not. That means this will change instructor availability in the system. And then this user case update instructor information should use the outcome of this. Right. Now that we have discussed about the use cases, we know what a use case is, we know what a actor is, we know now what a relationship is, the type of relationship we call users, right? Let's look at the description. Now, when you want to create user cases, you look for the information, and especially this information you collected from the requirement modeling, especially in the beginning. So the first step is you need to identify actors and then functions, which actually, generated, initiated by the actors. So for each user case, you can have a what we call user case description, and then you can put it as a table, right? Something like this. Now, let's say we have a use case, add new student. So the name of the use case is add new student. And when you have use case, there should be a somebody interact with this. So in this particular case, we will list down all the actors. So the actor could be a student or manager. And in the description, we can say what is this use case. We can say this describe the process used to add a student into a fitness class, right? And this could be a success. If it is a success, then what happens? So that we will list. What are the alternatives, right? So one is success, one is actually, if it is not success, what is the alternative? Then what are the preconditions? What are the post conditions? What are the assumptions? So all these could be a list when you want to create a use case. In this particular case, add new student. So now let's look at how we can draw these diagrams. So when you are going to have this different user case and then the actors, their relationship, we can put it to show a visual summary of use cases within the system. There are a few things you have to do. First, you have to identify the boundary of the system. Usually this boundary we represent using a rectangle. And then we identify use cases. So we place the user cases on the diagram and design oval shapes. Then we know that there should be actors. So you add actors, and finally you show the relationships. You draw arrows. Right. Now let's look at an example. So auto service department. So this is the rectangle shape represent the whole information system. And here we have 3 use cases: create work order, update work schedule, and prepare invoice. Then we will put up all the external entities, the actors. We have customers, we have a mechanic, we have service right. Then we have relationship. So for example, customer first request the service with this use case, and then it will create the work order, and the service writer is the one who writes this. And then the mechanic, right, notified by the update work schedule, because once you do this, this will use the update work schedule, right, to create the work order. And then once you perform the work, right, you will create the prepare invoice and the service writer checks it. So this is a very simple user case where it represents the service department. Okay, I think that's enough for today to what we have discussed so far. To summarize what we did today's session, we finish our process description tools. We discussed 3 process description tools: structured English, then decision table, as well as decision trees. Then we look at object-oriented analysis. The object-oriented in analysis, we discuss different ideas. So far, we have discussed the object diagrams, how objects are interact each other. as well as user case diagrams, right? There are a couple of more coming, but I think we'll stop at this point. Make sure you go through the material and also the book I will share. Already I shared some of them, but I will share the new chapter as well. So please go through the, and we'll meet next week in the mentoring session. Okay, that's all for today then. We'll meet next week.